In this video, we are still looking at limits at infinity, and I'm going to call this rationals part 2. Rationals, of course, being fractions, so what I'm interested in is what happens if I had something that looks like that, or if I had something that looks like that. All right, awesome. So let's go ahead and talk about what occurs when I'm doing a combination of e's with polynomials, okay? Remember that when we are looking at limits as we go to infinity, I'm curious to know if these are going to level off or blow up, okay? So one of the first things we need to kind of look at is what's dominating. Is the top dominating? Is the bottom dominating? Or are they keeping pace? Okay, so one of the kind of facts that you need to know is that e to the x pretty much grows faster than x to almost any power. Now, when I say almost any power, it's because if this was e to the x and this was x to the 1,000th, okay, then this guy's winning. But most of the time, we're going to be looking at things like x squared, x cubed, x to the 4th, x to the 5th, those kinds of things, and e to the x is still going to grow faster than those guys, okay? So I'm going to write most any powers, okay? So anything that we're going to touch, okay? So what's happening then, if you know this fact, is that this function is winning this battle. E to the x is going to dominate. So it doesn't really matter how gigantic this bottom is. This is going to be way bigger, okay? So since the top is going to be way bigger, this is not going to put a dent in that. So this is actually going to end up going to infinity, okay? Now, why is that? Again, think about if you were to grab your calculator and put in a number like 100. E to the 100th is way bigger than 100 cubed plus 4. Even when I divide it by that, it's still going to survive the division and still be growing to infinity. Okay. Now down here, e to the x is in the denominator. Okay. So since e to the x is in the denominator, when I plug in infinity, I get e to the infinity plus 1. So this is going to be huge. Huge, huge, huge. And even though the top is big, this bottom's going to be way bigger. So like if I were just to plug in a number like 100 squared divided by e to the 100 plus 1. So this bottom's going to be gigantic. It's actually going to force the whole thing to be 0. So if your bigger function is in the bottom, it's going to slam it to 0. If your bigger function is in the top, it's going to make it go to infinity. As I'm talking about x going to positive infinity. Okay, now, little bit of a tricky thing, though, is when we talk about negative infinity. The reason why negative infinity is a little bit tricky is that think about e to the x. Okay. As I go to negative infinity, this is the same thing as, if you will allow me to write this, e to the negative infinity, which would be 1 over e to the infinity. So 1 divided by a huge number is 0. So you have to be careful when you're playing with e's that you are paying attention to the infinities. Generally, when we're doing comparisons like over here, we will be going to positive infinity. But our answer would change if we were doing negative infinities. For those who are a little bit slow and wondering, hey Jen, what do you mean that that's going to go to 0? Well, think about the e to the x graph. This side is blowing up really fast, right? But this side is leveling off and getting closer to 0. So that's what's going on here. As I'm walking on this graph to the left, it's flattening off to 0. Okay, so be very, very careful in the details as you're doing your homework, that you're paying attention to which infinities you're playing with and how that will affect your overall comparisons. All right, good luck.